Good afternoon. This is Irshad, your physics teacher. I decided you will get the solution of the all numericals every day or week by week or every week. Thank you. The first one, we're going to deal with calorimetry numericals. Let we see the first one. Why? Importing heat to your body. Its temperature rises by 15 degrees Celsius. What is the corresponding rise in temperature on Kelvin scale? We know that one division rise in degrees Celsius scale equal to one division rise in Kelvin scale, because both scales are have same number of divisions. So the temperature in Kelvin scale is T equal to 15 Kelvin. Question 2. Calculate the heat capacity of a copper vessel of mass 200 grams if the specific heat capacity of copper is 410 joule by kg Kelvin. How much heat energy will be required to increase the temperature of the vessel in part A from 25 degrees Celsius to 35 degrees Celsius? Okay. So what is given in the question? Let me see first. Mass given. This mass is represented by M. It is in CGS system, so I will convert into SI system 0.2 kg. This is a specific heat capacity. Now thermal capacity need to find out. Thermal capacity is represented by T dash equal to Q by delta T. This is the one formula, and it can also be written as AMC, where M is the mass of the substance, C is a specific heat capacity, right? Then we are going to find the part A, heat capacity. So C dash equal to mass 0.2 kg, so into, and a specific heat capacity is 410. 410. If we can multiply, you will get 82 joule by Kelvin. So it is a heat capacity or thermal capacity. The next one, he asked to find the heat energy. The heat energy part B, Q equal to mc delta T, where m is the mass of the substance, C is a specific heat capacity, delta T is a change in temperature, and delta T can be written as T2 minus T1, where T1 is the initial temperature, T2 is a final temperature. Given T2 is 35 degrees Celsius, T1 25 degrees Celsius, that is equal to 35 minus 25, that is equal to 10 degrees Celsius. This is change in temperature. Then I will substitute here. The mass is 0.2. A specific heat capacity is 410, and the rise in temperature 10, that is equal to, so this decimal point and this 10 will get cancelled. Answer you will get 8, 4, joules. This is the heat energy. So what we have done? We have taken the two formulas. One is heat capacity, the other one is heat energy. Heat capacity is represented by ratio of heat energy by change in temperature, otherwise MC, product of mass into specific heat capacity. The heat energy is depend on three factors like mass of the body, nature of the body, and change in temperature. So Q equal to MC delta T. Question 3. A piece of iron of mass 0.2 kg has a heat capacity of 966 joule by Kelvin. Find the heat energy needed to warm it by 15 degrees Celsius. Find its specific heat capacity in SI system. So what is given in the question? Given mass in SI system, a specific heat capacity given, and there is a rise in temperature 15 degrees Celsius. What we need to find? The heat energy need to find. After that, this specific heat capacity in SI system. This is the M. This is C dash. This is delta T, change in temperature. First, energy need to find out. So we now only we have seen the formula. C dash equal to Q by delta T. That implies Q equal to C dash delta T. What you will get? That implies C dash 966, change in temperature 15 degrees Celsius. Okay, now multiply to get the heat energy value. Q equal to, okay, now I'm multiplying 966 into 15 equal to 14490 joules. This is the first one. Now the second one we are going to find. I need to find the specific heat capacity. We use a regular formula like Q equal to M C delta T. Then C equal to Q by M delta T. Then C equal to, what is the value of C here? Q is we found 14490 divided by mass is 2 into change in temperature 15. That implies 14490 divided by 13. 0 get cancelled. So finally we have C equal to 1449 by 3. Let's divide to get the answer. What I will get for C? 1449 divided by 3. We will get 483 joule by kg Kelvin. So in this question, I have used two formulas. The one is C dash equal to Q by delta T. The other one is Q equal to MC delta T. The next question. Calculate the amount of heat energy required to rise the temperature of 200 gram of copper from 20 degrees Celsius to 70 degrees Celsius. Specific heat capacity of copper 390 joule by kg Kelvin. So what is given here? Given mass is 200 grams. Initial temperature T1 is 20 degrees Celsius, T2 is 70 degrees Celsius, and the C is given 390 joule by kg Kelvin. Mass must be converted into kgs. What you will get the mass here? 0.2 kg. Then we have a formula to find the heat energy. Q equal to mc delta T. What is the value of m? Good, 0.2. T value 390. Temperature difference 70 minus 20, that equal to 0.2 into 390 into 50, that equal to, if you can multiply you will get like 0.2 into 50, 0 0 get cancelled 10, so you will get 3900 joules the heat energy. What I have done, mass given in CDS system, I converted into SI. So 200 grams equal to 0.2 kg. Initial temperature, final temperature, a specific heat capacity given in SI system. So I have taken the formula Q equal to mc delta T, and then the answer is 3900 joules. The next one, 1300 joule of heat energy is supplied to raise the temperature of 0.5 kg of lead from 20 degrees Celsius to 40 degrees Celsius. Calculate specific heat capacity of lead. Okay, so what is given in the question? This is Q given, mass, initial temperature T1, final temperature T2. So what we need to find out here? We need to find a specific heat capacity C of the lead. We have a formula Q equal to mc delta T. In the question, everything given, every physical quantity given in SI system. So no need to convert from one system to another. That equal to mass 0.5. C we don't know. So CC as it is. The delta T temperature 40 minus 20. What is the heat energy given? 1300. Then 1300 equal to 0.5 into 20 into C. 1300 equal to, if we can multiply 0.5 into 20, we'll get 10 into C. 0 0 on both sides will get cancelled. C equal to 130 joule by kg Kelvin. So once again, the given physical quantities in question 5 all are in SI system. Heat energy, mass, of course temperature T1 and T2. We have only one formula and direct it. Q equal to mc delta T. Then finally I found the answer C equal to 130 joule by kg Kelvin. This is the next question. My dear students, pause the question and try to solve it. A car's cooling system uses water to absorb heat from the engine. If 5 kg of water absorbs 420 kilojoule heat, what is the temperature increases of water? A specific heat capacity of water equal to 4200 joule by kg Kelvin. For this question, what we need to find? Temperature increase. What is given? Mass, heat energy, heat capacity, a specific heat capacity. So it is given in SI system. It is given Q it is, and this is the C. I need to find the temperature difference. Okay, so before I will write the formula. Q equal to 420 kilojoules. 420 kilojoules is nothing but 420,000 joules. It is 1 kilojoule equal to 1000 joules. So just multiply with 1000. A formula is Q equal to M C delta T. 420,000 equal to mass by C is 4200 into delta T temperature. Two zeros get cancelled. 42 1 ja, 42 100 ja. We have 100 equal to 5 delta T. Delta T equal to 100 by 5. That equal to 20 degree Celsius. So what we have done in this, we found the difference in the temperature. What is given in the question? Mass, heat energy, and specific heat capacity of water. Question 7. Find the time taken by a 500-watt heater to rise the temperature of 50 kg of material of a specific heat capacity 960 joule by kg Kelvin from 18 degrees Celsius to 38 degrees Celsius. Assume all the heat energy supplied by the heater is given to the material. So what we need to find is the time need to find out. What is given? Power given, mass, C value, of course. So given here T1, T2, initial temperature and final temperature. So T1 is the initial, T2 is a final given. So this is T1 it is. So we know power equal to rate of doing of work. It can also be written as P equal to 2 by T, right? So from this I will write T equal to 2 by P. Therefore time T equal to Q M C delta T divided by power P. All physical quantities are given in a system, so direct take substitute to the equation. Mass is 50 into C is 960 into temperature difference 20 degrees Celsius by power is 500. 0 0 get cancelled. 5 1 ja, 5 10 ja. Time t equal to 9 6 into 10. Then time t equal to 960 seconds. Okay, if do you want to convert it into minutes, you must divide 960 by 60. Then time you will get in minutes. It is 1 6 minute. So what we have done in this question, we have taken the new formula when compared to the previous one. That is the power, the rate of doing of work. Work is a form of any other form of energies. So W can be written as Q. So P equal to Q by T and T equal to Q by P, where M is the mass of the material, C is a specific heat capacity of the material, delta T is a rise in temperature, P is a power. Okay, so finally we found the time. The next one, this is little important. Question number 8. If a truck uses 10,000 liters of water to extinguish a fire, cooling down the burning material from 500 degrees Celsius to 100 degrees Celsius. If the temperature of water increases by 40 degrees Celsius, how much energy is absorbed by it? A specific heat capacity of water equal to 4200 joule by kg Kelvin. Here given 10,000 liters. Material is a water. The water temperature rises increases by 40 degrees Celsius. A specific heat capacity given 4200. Only for the water. Only for water. 1 liter of water equal to 1 kg. 1 liter of water equal to 1 kg. Then the mass of the water can be written as mass of the water equal to 10,000 kg. 10,000 kg. Need to find the heat energy, and delta T is given 40 degrees Celsius. To find the heat energy, we have a formula Q equal to M delta T. M is 10,000 into C is 4200. The change in temperature is 40 degrees. Right. How many zeros are there? 1, 2, 3, 4, 5, 6, 7 zeros. So shall I write this is? Before I will write 10 power 7. Just I will multiply 42 into 4. 4 2 ja 8 and it is 16. 168. So I will write 168 0 0 0 0 0. How many 6 and 7 joule of energy? We will write it is 168 into 10 power 7 joules. We found here how much energy is absorbed by the water. We did not find how much energy lost by the material. So keep in the mind here the most important thing, 1 liter of water equal to 1 kg. We'll go for the next one. An electric heater of power 600 watt raises the temperature of 4 kg of a liquid from 10 degrees Celsius to 15 degrees Celsius in 100 seconds. Calculate the heat capacity of 4 kg of liquid, a specific heat capacity of liquid. Given in the question is power P, mass of the liquid M, initial temperature, final temperature, time given. Okay, in the past problem, we have seen power equal to heat energy by time. That implies Q can be written as P into T. Then Q equal to, what is the P value? 600 watts. T value 100 seconds. Then QR will get 60,000 joules. Got it? Then we have a formula to find heat capacity is C dash equal to Q by delta T. That equal to Q is 60,000 by change in temperature is 5. Then you will get heat capacity C dash equal to 2 1 ja, 5 1 ja, 5 12 ja. I means you will get 12,000 joule by Kelvin. This is the heat capacity. And now we are going to find the specific heat capacity. Directly we can use here C dash equal to MC. C dash equal to MC. This is the part A it is. Where is the cursor? Appearing to you. This is 1 it is. Now we are going to find 2. C dash we found 12,000. Mass given 4. C need to find out. So C equal to, you will get 3,000 joule by kg Kelvin. Same formula, power equal to heat energy by time. From that I found the heat energy Q equal to 60,000 joule. Heat capacity C dash equal to Q by delta T. C dash equal to 12,000. Specific heat capacity C dash equal to MC. And finally C equal to 3,000 joule by kg Kelvin. The next question. 0.5 kg of lemon squash at 30 degrees Celsius is placed in a refrigerator whose rate of heat removal is 30 joule by second. How long will it take to cool the lemon squash to 5 degrees Celsius? A specific heat capacity of lemon squash equal to 4200 joule by kg Kelvin. So what is given in the question first? Let me identify. So here the mass is given 0.5 kg. This is the initial temperature T1, T2 final temperature, power P, and this is the C. So what we need to find here? We like to find how long it will take to, we need to find the time. The power formula I will write. Power equal to heat energy by time. Then time equal to heat energy by power. Then time T equal to M C delta T by time T equal to mass 0.5 by specific heat 4200 into change in temperature. So 30 minus 5, 25 divide by 30 power, yeah, 30 it is. Possible for cancellation. 0, 0 get cancelled. Then what I will get? 5 into 42 into 25 divide by 3. Then time t equal to 125. 5 into 25, 125, and 3, 4, yeah, 3, sorry, not 3, it is 3, 14, yeah, 42. So here I will write, sorry, this, here I will write 14. Now multiply time t equal to 125 into 14. Pause the video and try to multiply it. 125 into 14 equal to 1750 seconds. If do you want in minutes, let divide by 60. 60. You will get time t equal to 29.2 minutes approximate. Okay, otherwise if do you want time t equal to 29 minutes and 12 seconds. Okay, small difference, this and last problems. Time minutes as well as in seconds. So time t equal to 29 minutes 12 seconds. The next one, a mass of 50 gram of certain metal at 150 degrees Celsius is immersed in 100 gram of water at 100 degrees Celsius. The final temperature is 20 degrees Celsius. Calculate the specific heat capacity of the metal. First, find out which is the hot body temperature. Okay, then this is the highest temperature, then T1 temperature. Its mass is M1. The other mass is M2. This is the T2 temperature it is. And final temperature is T. What we need to find? We need to find heat capacity, a specific heat capacity of the metal. And it is given 4.2 for water. So this is method of mixture principle. Net gain equal to net loss. So I will write here net gain equal to net loss. Formula I will write gain now. So M1 C1 of T1 minus T equal to M2 C2 of T minus T1, where T1 is the highest temperature, T2 is the lowest temperature, T is a moderate temperature, where M1 is a mass of highest temperature body, M2 is a mass of lowest temperature of the body, right? Where M1 is a mass of a certain metal, where M2 is a mass of water, and we have to find a specific heat capacity of the metal. So I will write the given, the mass 50, see we don't know, and T1 is 150, T is 20, M2 100, specific heat capacity 4.2, and temperature is 20 minus 11, right? Okay, here I will do the cancellation. 51 ja, 52 ja. So C equal to, if you can subtract 150 minus 20, I will get 130. So C into 130 equal to 2 into 4.2 into 9. It C equal to 8.49 by 130. Let's multiply and divide it. 2 into 4.2 into 9. It is equal to 75.6 divided by 130 divided by 130. It is 0.582 approximate. That implies C equal to 0.582. Units you will get here joule by gram degree Celsius. So answer is 0.582. So this is the first one. This is the first problem we face from method of mixture. Net gain equal to net loss. Who is gaining the heat energy here? Who is gaining the heat energy? Water is gaining the heat energy. Who is losing the heat energy? Metal is losing the heat energy. We'll go for the next one. 42 gram of water at 50 degrees Celsius in a beaker is cooled when 50 gram of copper at 18 degrees Celsius is added to it. The content are stirred till a final constant temperature is reached. Calculate the final temperature. A specific heat capacity of copper is 0.39 joule by gram Kelvin, and that of water 4.2 joule by gram Kelvin. State the assumption used. Here the assumption you will get, there is no loss of heat energy. There is no loss of energy. This is the assumption here. So first I will find the highest temperature here. This is 50 is the highest. So I will write it as a T1. And then this is the mass M1 it is. This mass is the M2. This temperature is a T2. The final temperature T we need to find. T equal to what? Same method of mixture formula. What is the equation we have till? We have seen what we have seen. M1 T1 delta T. I will erase. I will write the correct component. M1 C1 of T1 minus T equal to M2 C2 of T minus T2. So M1 mass 45. C1, okay, this is the C1. C1 it is, and this is the C2. No. This is the C2 it is. This is the C1. C1 it is. So 45. 45 into, and C1 is a 4.2, temperature 50 minus T equal to mass 50 0.39 of T minus 18. Okay, here I will use the phi table. Phi 9 ja, phi 10 ja it is. Then I have a equation here, 9 into 4.2 of 50 minus T equal to 10 into 0.39 of T as 18. Now multiply 9 into 4.2. You will get 37.8 of 50 minus T equal to 3.9 of T minus 18. Okay, multiply it. Multiply it. Then 37.8 into 50 minus 37.8 into T equal to 3.9 into T minus 3.9 into 18. Okay. Small multiplications. Once again, please try to multiply 37.8 into 50. 8 into 50. It is equal to 1890. 8 it is minus 37.8 T equal to 3.9 T minus 3.9 into 18, 70.2 is 70.2. Okay, numbers one side, T terms other side. So I will write here 1890 plus 70 point equal to 3.9 plus 37.8 it is. Okay, so we will add it 1890 plus 70.2. It is equal to next space I will use. It is equal to here on the top I will write. It is a that implies 1960.2 equal to the next one 3.9 plus 37.8 equal 41.7. So it is 41.7 T it is. Then divide it, you will get the value of T here, final temperature. So 1960.2 divide by 41.7, you will get 47. So T equal to 47 degrees Celsius. Now this is the final temperature. Final temperature. Okay, boys, I'm giving you 20 seconds for you. Please try to solve the question number 30 using the same method of mixture. Okay, I think you have done it. We'll see. 200 gram of hot water at 80 degrees Celsius is added to 400 gram of cold water at 10 degrees Celsius, neglecting the heat taken by the container. Calculate the final temperature of the mixture. So here, when compared to last two, this one is easy because both substances are water and water, cold water and hot water. So mass, this is the highest temperature, right? So this is the T1, this is the M1, this is M2, this is T2. Yeah, both are same na specific heat, it will get cancelled. Same formula I will use, method of mixture 1. Formula is M1, T1, T1 minus T equal to M2, C2, T minus T2. So what is the mass M1 here? 200 into C. So why I have taken C? There is a common for the both. It will get cancelled. And T1 is 80 minus T. M2 400. T C. And final temperature we don't know. The lowest temperature 10 degrees Celsius. So on both sides C get cancelled. C get cancelled. 200 1 ja. 200 2 ja. The next step we have 80 minus T equal to 2 of T minus 10. 80T equal to 2T minus 20. Then you will get 80 plus 20, 100. 2T plus T, 3T. That implies T equal to 100 by 3. Then final answer we will get T equal to 33.33 degrees Celsius. Celsius it is. This is the 13th one. Same formula, but nature is same here. So I have written C on both sides of the equation. The C will get cancelled. The remaining easy to solve it. Go with the next one. The temperature of 600 gram of cold water rises by 15 degrees Celsius when 300 gram of hot water at 50 degrees Celsius is added to it. What was the initial temperature of the cold water? What was the initial temperature of the cold water? So this is the highest temperature T1 and its mass is M1. This is the different here. I will write later. This is the M2. Here he said rises here. Then 15 equal to this 15 equal to final temperature minus lowest temperature. It is. And both are said water and water. So this is the water, cold water. This is the hot water. C will get cancelled. We have a equation from method of mixture. M1 C1 of T1 minus T equal to M2 T2 of T minus T2. M1 is 300. Anyway, C and both sides will get cancelled. I don't write it. And the highest temperature is 50 minus T equal to a cold water temperature, a mass 600. 100 into it is 15. Okay, 300 1 ja, 300 2 ja. 50 minus T equal to 30. Then T equal to 20 degrees Celsius. This is the final temperature. And according to the given T minus T2 equal to 15 given. T we found final temperature 20 minus 15 equal to T2. That implies T2 equal to 5 degrees Celsius. This is the lowest temperature of the cold water. Lowest temperature of cold water. Okay. The next one. 1 kg of water is contained in a 1.25 kilowatt kettle. Calculate the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point 100 degrees Celsius. The specific heat capacity of water is, oh, of course, this is also we have done already. So once again, we will write what is given here. This is the mass, power given, kilowatt, convert into watt. And we have to find the time. Initial temperature is 29. The final temperature is 100 degrees Celsius. And heat capacity given 4.2. 4.2. Okay. Then how we can solve it? Okay, I will take the heat capacity into the kgs. So we'll write here itself C equal to 4200 joule by kg Kelvin. It is well known about water. And we have a formula power P equal to heat energy by time. That implies time T equal to heat energy by power. And power P is given here 1.25 kilowatt. I mean 1250 watt it is. 1 kilowatt equal 1000 watts. So I multiply with 1000. Then finally we have the equation time T equal to Q is, we don't know. So I will write M C delta T by P. That implies time T equal to M value is 1, C value is 4200 into change of temperature 700 minus 25. So 75 you will get, divide by power value is 1250. 0 0 will get cancelled. 75 ja, sorry, I mean 25 3 ja, 25 5 ja. So what we have final temperature T equal to 420 420 into 3 divided by 5. That equal to, and that implies T equal to, please, you boys and girls, try to multiply it. 420 into 3 is equal to 1250. 1250 it is. 125055. Divide with 5 please. It is equal to 252 seconds. If do you want only in minutes, we will write it is, okay, we will write it is 4.2 minute. Okay, if do you want it in minute as well as in seconds, so we will write time T equal to 4 minute 12 seconds. Thank you. Okay, today we have done the numericals of calorimetry of part A. I mean, just A completed. In the coming class, we are going to do the part B problems also. Thank you. Thank you very much.